Now let's move ahead and look at the ACUPRO software. We will be making a measurement of sound absorption coefficient using the ACUPRO measurement system that was demonstrated in a previous video. When we open the ACUPRO software, the menu we see is exactly what you now see on the screen. In fact, this is the one and only screen that you will see in all of ACUPRO. There's no jumping between menus to set levels or microphone sensitivities. All is controlled on this screen automatically by the software. To begin making a measurement, all we do is push the Start button. Once we do that, we will be making an FRF or transfer function measurement with 100 averages. Then the system will stop and we'll be able to calculate the sound absorption coefficient just by hitting the Calculate button at the bottom of the screen. Finally, we will show how to save the data in an Excel file. By clicking on the Setup button, we can see from the Setup tab that our FRF or transfer function will be measured over a frequency range of 0 to 5,000 Hz with a frequency resolution of 12.5 Hz. To begin the measurement, we push the Start button. We now see the time domain signal of channel 1, channel 2, and the transfer function as it accumulates. We're still only about halfway through the accumulation, but already the transfer function is quite smooth. We see at the top the magnitude of the transfer function. In the middle of the screen, the phase angle of the transfer function, and at the bottom of the screen, the coherence of the transfer function. ACUPRO is now asking us if we want to save this transfer function or do we want to take another. So we will accept it. Having accepted the transfer function that we just measured, we will go down and make a calculation of the sound absorption coefficient by clicking the Calculate button. We now see in the upper part of the plot the sound absorption coefficient versus frequency for a range of 0 to 5,000 Hz. We can also observe the specific sound absorption at a given frequency by moving the cursor as shown here. On the lower plot, we have a toggle that allows us to observe some of the other calculated quantities, such as the real and imaginary part of the acoustical impedance, the real and imaginary part of the acoustical admittance, and finally the real and imaginary parts of the sound pressure reflection coefficient. All very desirable quantities in addition to the sound absorption coefficient shown at the top. We can also look at the sound absorption coefficient in 1/3 octave bands over the frequency range of interest merely by selecting this tab. To save the data in an Excel file, we simply come down and click the Save button. Having saved the data in an Excel format, we can look at the Excel file as shown here. And we see that the ACUPRO system has saved a lot of information for us. We see, for example, the job description, the date and time of the measurement, the temperature conditions of the measurement, the microphone parameters, the number of lines, and the frequency resolution of the measurement. Referring to the data, we have in the first column the narrowband frequency points, in the second column the sound absorption, in the third and fourth columns the real and imaginary part of the acoustical impedance, in the fifth and sixth columns the real and imaginary parts of the acoustical admittance, and in the last two columns the real and imaginary parts of the pressure reflection coefficient. On the right side, We see the sound absorption coefficient in 1/3 octave bands over the frequency range of interest. In addition to this tabulated data, we have created two charts shown here. We have a chart of the narrowband sound absorption coefficient versus frequency. And in a second plot, we see the sound absorption coefficient in 1/3 octave bands from 100 to 5,000 hertz. From this short demonstration, we see that the ACUPRO software is extremely simple to use to make measurements of sound absorption coefficient. The ACUPRO software can be used by a technician or lesser trained person, and there's no need to use a general purpose spectrum analyzer. Thank you very much for your time today.